The Space Shuttle Columbia soared into the sky on April 12, 1981. It was a moment of immense national pride. The United States had launched its first reusable spacecraft. Columbia promised a new era of space exploration. Its significance was undeniable. Columbia's launch marked the beginning of the Space Shuttle program. Millions around the world watched on television. The roar of the engines, the billowing smoke, and the sight of the shuttle ascending into the heavens captivated viewers. It was a testament to human ingenuity and our unyielding desire to explore the cosmos. Columbia represented a bold vision for the future of space exploration. It was designed to be a workhorse, a space truck that could ferry astronauts and payloads into orbit regularly. This reusability was a key feature. It promised to lower the cost of space travel. The shuttle was a technological marvel equipped with state-of-the-art systems. Columbia's early missions were met with great success. They deployed satellites, conducted scientific experiments, and even launched the Hubble Space Telescope. The shuttle program was living up to its promise. However, the complexities of space travel and the unforgiving nature of the environment meant that danger was always lurking. The Space Shuttle program was a complex undertaking. It involved thousands of engineers, scientists, and technicians. The program was also incredibly expensive. Each mission cost hundreds of millions of dollars. The Space Shuttle program was a symbol of American technological prowess. The shuttle itself was a marvel of engineering. It was designed to withstand the extreme temperatures and stresses of launch and re-entry. The shuttle's reusable design was both its greatest strength and its greatest weakness. Despite its complexity and the inherent risks involved, the Space Shuttle program captured the imagination of the world. It inspired a generation of scientists, engineers, and astronauts. The program demonstrated that humanity could push the boundaries of what was possible. However, it also highlighted the importance of vigilance, meticulous planning, and the need to respect the unforgiving nature of space. Even in its early years, the Space Shuttle program faced challenges. Engineers and technicians worked tirelessly to address technical issues. They knew that even a small malfunction could have catastrophic consequences. One recurring issue was the thermal protection system. The tiles that made up this system were particularly vulnerable to damage during launch. Debris from the external tank or solid rocket boosters could strike the tiles, causing them to detach. Another concern was the solid rocket boosters. The seals that held segments of the boosters together were known to erode during launch. This erosion could lead to hot gases escaping and potentially causing a catastrophic failure. Despite these concerns, the Space Shuttle program continued. Each mission was a learning experience, with engineers and technicians meticulously analyzing data to improve safety and reliability. Section 5. Foam strikes and their implications. The issue of foam strikes became a recurring concern for the Space Shuttle program. During liftoff, pieces of insulating foam from the external tank would often detach. These pieces could strike the shuttle's delicate thermal protection system. Engineers and technicians were aware of this problem. They implemented various modifications to the external tank's insulation. They also developed procedures for inspecting the shuttle's thermal protection system after each launch. Despite these efforts, foam strikes remained a persistent problem. In some cases, the damage caused by foam strikes was not detected until after the mission. The Space Shuttle Columbia's final mission would tragically prove these concerns to be prophetic. A large piece of foam detached from the external tank during launch and struck the shuttle's left wing. This seemingly minor event would have devastating consequences, ultimately leading to the loss of Columbia and her crew. Section 6. A history of close calls. The Space Shuttle program had a history of close calls. These incidents served as stark reminders of the inherent risks of space travel. One such incident occurred during the STS-51L mission in 1986. The Space Shuttle Challenger exploded shortly after liftoff due to a failure of an O-ring seal in one of the solid rocket boosters. This tragic accident grounded the shuttle fleet for 2 years and led to a comprehensive review of the Space Shuttle program's safety procedures. Another close call happened during the STS-93 mission in 1999. The Space Shuttle Columbia experienced a fuel leak during launch, causing one of the shuttle's 3 main engines to shut down prematurely. The remaining two engines were able to compensate, and the shuttle and its crew safely reached orbit. These incidents highlighted the fact that space travel was an inherently risky endeavor. Despite the best efforts of engineers and technicians, failures could and did occur. Section 7. The Fatal Flaw. The Space Shuttle. Columbia's final mission, STS-107, began on January 16, 2003. The crew consisted of 7 astronauts, a diverse group of highly trained individuals. The mission was dedicated to scientific research. During Columbia's ascent, a piece of insulating foam detached from the external tank and struck the shuttle's left wing. The impact created a breach in the thermal protection system. The astronauts and mission controllers were unaware of the extent of the damage and continued the mission as planned. Unbeknownst to the crew, the breach allowed superheated gases to penetrate the shuttle's structure during re-entry. As Columbia descended through the Earth's atmosphere, the heat and pressure inside the wing continued to build, leading to a catastrophic structural failure. The shuttle broke apart over Texas and Louisiana. There were no survivors. This tragic event underscored the critical flaw in the shuttle's design. Section 8. Re-entry and disaster. On February 1, 2003, the Space Shuttle Columbia was scheduled to return to Earth. The crew prepared for re-entry, donning their pressure suits and taking their positions in the flight deck. Excitement filled the air at Mission Control in Houston. As Columbia entered the Earth's atmosphere, sensors began to detect unusual readings. Temperatures on the left side of the shuttle were rising rapidly, and hydraulic systems began to fail. Mission Control attempted to contact the crew, but their calls went unanswered. The world watched in horror as live television feeds showed Columbia breaking apart over Texas and Louisiana. The loss of Columbia and her crew sent shockwaves around the globe, leading to the immediate grounding of the remaining space shuttles. The world mourned the loss of 7 brave astronauts and grappled with the realization that space exploration, while awe-inspiring, was not without its profound risks. Section 9. Investigating the tragedy. The loss of Columbia and her crew led to an extensive investigation. The Independent Columbia Accident Investigation Board, CAIB, was formed to determine the cause of the accident and recommend changes to prevent similar tragedies in the future. The CAIB investigation was thorough and exhaustive. They analyzed debris, reviewed mission data, and conducted interviews with NASA personnel. The investigation revealed a combination of technical and organizational factors that contributed to the disaster. The primary technical cause was the foam strike during launch, which created a breach in the thermal protection system. The board also identified organizational factors, including a culture of complacency within NASA and a lack of communication between engineers and managers. The CAIB report was highly critical of NASA's safety culture and concluded that the agency had failed to learn from previous close calls. It recommended sweeping changes to improve safety and prevent future accidents. Section 10. Lessons learned, legacies honored. The loss of Columbia and her crew was a profound tragedy. It served as a wake-up call for NASA and the entire space community. In the wake of the disaster, NASA implemented significant changes, restructuring its safety program and improving communication channels between engineers and managers. NASA also developed new technologies to inspect the shuttle for damage during and after launch. The legacy of Columbia and her crew lives on, inspiring future generations of scientists, engineers, and astronauts. Their dedication to exploration and discovery serves as a reminder of the indomitable spirit of humanity. The Columbia disaster underscored the importance of learning from failures. By studying these lessons and applying them to future endeavors, we can continue to push the boundaries of space exploration while mitigating risks and ensuring the safety of those who venture beyond Earth. Section 11. Columbia's enduring legacy. The Space Shuttle Columbia's fiery demise over the skies of Texas was a stark reminder of the inherent dangers of space travel. It served as a tragic punctuation mark on an era of space exploration characterized by both triumph and tragedy. Despite the tragedy, Columbia's legacy continues to inspire. The astronauts aboard STS-107 embodied the spirit of exploration and the pursuit of knowledge. Their dedication to science and their willingness to push the boundaries of human understanding came at a high cost. but their sacrifice should never be forgotten. The lessons learned from Columbia's final mission have had a lasting impact on the space community. The Space Shuttle Columbia may be gone, but its memory lives on, serving as a reminder of both the incredible achievements and the inherent risks of space exploration. As we continue to venture further into the universe, we carry with us the lessons learned from Columbia's legacy, striving to honor the sacrifice of those who came before us by prioritizing safety, embracing innovation, and never losing sight of the wonder and inspiration that draw us to the stars.